Okay, so now we're going to tackle adding, subtracting, multiplying, and dividing irrational numbers, and also rationalizing their denominators. So let's see. Let's take a look at the two rules that we're going to use. The first rule is the product rule, which I introduced in the last video, but now we're going to look at it in the opposite direction. Now we're going to take two radicals that are separate and combine them into a single radical. So we have two radicals that are separate. We're going to take each radicand, A and B, and we're going to just find the product of them. And then there's also a quotient rule that says if you have the square root of A over the square root of B, is equal to the square root of A over B. So we have the product rule and the quotient rule as our two tools. And also, we have to know that in order to combine things as like terms, they have to have the exact same image after the number. So for instance, 3 of those plus 2 of those is equal to 5 of those. You don't even have to know what those are. Alright? So as long as you have a number in front of an image and another number in front of the same image, you can count those images. Okay? That's what combining like anything means. It means you have a certain number of one thing here and a certain number of the exact same things over here, and you're going to combine the number of those things together. Alright, so let's get started here. Those are the tools that we're going to use. So the first one I want to look at, part A. The square root of 3 times the square root of 21. This is a product. We're doing the multiplication. Well, the product rule says I can take each individual radicand and make a single radicand that contains their product. Because I'm multiplying the two radicals, I can just multiply their radicands together. And here I get the square root of 3 times 21 is 63. But you can't leave that answer. Just like when you learn to simplify fractions, once you learn how to simplify radicals, you can never again leave a radical in unsimplified form. So we have to simplify this radical. In order to simplify the radical, I need to find a perfect square that is a factor of that number. And a perfect square that's a factor of 63. 9 goes into 63 7 times. And then I can split that radical up using the product rule again. So the same rule that I used to put these together is the same rule I'm using to now split it back up. To give me, this is equal to the square root of 9 times the square root of 7. And then the final answer becomes, well, the square root of 9 is 3, and the square root of 7 is the square root of 7. So this would be the final answer. If I multiply the square root of 3 by the square root of 21, the answer is the square root of 63. But when I simplify the square root of 63, I get 3 square roots of 7. All right, let's try another one. This is part B. Part B, we'll do the square root of 20 over the square root of 5. Okay, well, this one I'm going to use the quotient rule. The quotient rule says if I'm dividing two irrational numbers, then I can just make one big radical and do the quotients of the two radicands. So it's going to be the square root of 20 over 5. And actually, I know what 20 divided by 5 is. 20 divided by 5 is the number 4. And then the square root of 4 is just 2. So the final answer here is 2. So that's the multiplying and dividing. To do the multiplication, use the product rule. To do the division, use the quotient rule. Now let's talk about adding and subtracting. So this is addition. 2 Okay, you see I have 2 of those things here, and over here I have 6 of those exact same things. See, you don't even have to know what the things are necessarily. You know there are 2 here and 6 here, so that makes a total of 8 of those things. 8 of those, okay? We're just counting the number of things that we see. All right, let's try this one. Let's try 2 square roots of 18 minus 3 square roots of 50. Now we have 2 of these things and negative 3 of something that's completely different. So I can't do the same thing that I did up here, say, hey, I have 8 of those. I first would have to simplify each of these radicals to see if they become similar things. So that's what I'm going to do. I'm going to go through and simplify each radical. So for this first radical, well, I need a perfect square that goes into 18. A perfect square that is a factor of 18 is 9. 18 is actually 9 times 2. I need a perfect square that's a factor of 50. Well, I know there's the number 25 that goes into 50, and 25 goes into 50 twice. So now I'm going to use the product rule and separate both of these radicals into 2 radicals. So I have 2 times the square root of 9 times the square root of 2 minus 3 times the square root of 25 times the square root of 2. Well, this is 2 times, and the square root of 9 is 3, multiplied by the square root of 2. And this is minus 3 times, well, the square root of 25 is 5 times the square root of 2. And here, now I have 2 times 3. I know what that is. That is 6 square roots of 2 over here. Minus 3 times 5. Well, that's 15 square roots of 2 over here. And now they actually are like radicals. Here I have 6 of those things, and here I have negative 15 of those things. So at the end of the day, I will have, well, 6 minus 15 is negative 9 of those exact same things, square roots of 2. So the final answer here, negative 9 square roots of 2. So when you're adding or subtracting irrational numbers, the key is to first simplify the radicals in each number, and then if you have like radicals at the end, combine the like radicals. So let's do one more example of adding and subtracting. Let's try 2 square roots of 7, 2 square roots of 7, plus 5 square roots of 28. Well, let's see. 7 is a prime number. The only factors of 7 are 1 and 7. So we can't simplify this radical anymore. That radical is already as simple as it can get. 28, on the other hand, has a factor of 4 in it, which is a perfect square. And the other factor would be 7. So the 28 can be broken down further. One of the factors is a perfect square, so I'm going to go ahead and do it. So we have plus, and then it's going to be 5 times. And then we're going to split this up using the product rule. It's going to be the square root of 4 times the square root of 7. And you have 2 square roots of 7. Well, once again, I know the square root of 4. That's the whole point of extracting that perfect square factor, is so you can actually take its square root. So I get 2 square roots of 7 plus 5, and then the square root of 4 is 2, and then times the square root of 7. So what we get is, once again, we have the 2 square roots of 7 just coming down. 5 times 2 is 10. And then we get this expression. And those are indeed like radicals. Once I do the simplification, I have 2 of the square roots of 7 here, have 10 of the square roots of 7 here. So in total, I have 12 square roots of 7 in total. So there you have it. That is the simplification and addition and subtraction of irrational numbers. All right, the last thing I want to do, I'm going to actually write the directions here. The last thing I want to do is something called rationalizing the denominator. So let's take a look at that. So rationalize the denominator here. Let's do this problem. 3 over the square root of 2. Well, to rationalize this denominator, if you notice, the denominator, or the bottom of the fraction, is what we call an irrational number. It's the square root of 2. If you were trying to represent that as a fraction, there would be no way of getting the numerator and the denominator to both be integers. So the square root of 2 is an irrational number. The square root of 2, we discussed that in a previous video. The square root of 2 is an irrational number. So you cannot divide by irrational numbers. Whenever there's a radical in the denominator of a fraction, you have to get rid of it. Here's how. You have to multiply that radical by something that's going to make the radicand, the thing underneath the radical symbol, into a perfect square. Well, the easiest thing to multiply 2 by in order to make it into a perfect square is another 2. So if I multiply the top and bottom of this fraction by the square root of 2, this is what happens. Well, 3 times the square root of 2 is just 3 square roots of 2. But the square root of 2 times the square root of 2 by the product rule is the square root of 2 times 2. So I get the square root of 4. But I know the square root of 4. The square root of 4 is actually a rational number. The square root of 4 is the number 2. So now I went from the fraction 3 over the square root of 2, which has an irrational denominator, to the fraction 3 square roots of 2 over 2. They're the same number, hence the string of equal signs, same number, but this one is a little bit better because the denominator of that fraction is a rational number. And it's always preferable to have denominators be rational. You don't want to have radicals in the denominator of your fractions. Let's do another one, part B. Let's try the square root of 2 over the square root of 27. All right, now this one is slightly different because the denominator is a larger number. You can go ahead and just multiply the top and the bottom by the square root of 27. That'll work, but you'll be working with much larger numbers. So the best thing to do is, before you start to rationalize the denominator, simplify the denominator first. Simplify the radical that's down there. You'll get the square root of 2, and the perfect square that goes into 27, the perfect square that goes into 27 is 9. And 27 is actually 9 times 3. So then you get the square root of 2 over the square root of 9 multiplied by the square root of 3, which is the square root of 2 over, well, we know the square root of 9 is 3, and then you still have that square root of 3. Okay, so you get this. You want the denominator of that fraction to be a rational number. You don't want to have this radical 3 in there. So what you're going to do is you're going to multiply the top and the bottom by whatever number is going to make that radicand a perfect square. Well, since you already have a factor of 3, it makes sense to multiply by another factor of 3 so that the radicand can become a 9, which is a perfect square. So we'll see the square root of 2 over 3 square roots of 3, and we're going to multiply the top and the bottom of this fraction by that radical that's still in the denominator. We're just like we did here, we multiply the top and the bottom by the square root of 2, the original denominator. Here we're going to multiply the top and the bottom by the irrational part here, the square root of 3. So we get this. On top, I'll get the square root of 2 times the square root of 3. On the bottom, I'll get 3 square roots of 3 times the square root of 3. By the product rule, I can multiply these two radicands, so I get the square root of 6 on top. Then I still have this 3 here, and by the product rule, I can also multiply these two radicands, so I got the square root of 9 in the denominator. I know the square root of 9. So it's the square root of 6 on top, and on the bottom, I have a 3 as a factor, but I also have as a factor the square root of 9, which is another 3. So the denominator is really just 3 times 3, and the final answer turns out to be the square root of 6 over 9. So it turns out that the square root of 2 over the square root of 27 is the same number as the square root of 2 over 3 square roots of 3, but that number, when you write it with a rational denominator, is the square root of 6 over 9. So it turns out this number is also equal to that number, and that one has a rational denominator. So that's how you're going to rationalize the denominator of the fractions that you're given.